Thank you for joining Once Changing the World. I'm your host, Eddie Avil, and today I'm delighted and honored to have with me Professor Pulin Agrawal, who's an engineer, researcher specializing in artificial general intelligence and cognitive science with a focus on the Lida, which is the Learning Intelligent Distribution Agent inspired by human cognition and the Global Workforce Theory. Professor Agrawal is currently affiliated with the Pennsylvania State University and has a background in both academic and applied research contexts with contribution that bridge neuroscience inspired AI and practical computation models. Professor, really appreciate you taking time being part of the podcast. Now, you've been invested in AI and even AGI since 2012. So you've been thinking about artificial general intelligence back then when even AI was not like very, publicly known. So it will be great if you could start with, what got you interested in artificial intelligence and what convinced you that we could someday build general purpose machines and maybe machines that could someday be, sentient?
Well, first of all, thank you, Eddie, for having me here. I started on this journey back in 2010-ish when I was uh, like a third year student or a junior in college, and I was just having a summer afternoon chat with my friend Ravi Agarwal, and we were talking about we both like C++ programming. We thought let's do a cool summer project, and we thought let's make a chatbot. And those times chatbots were just maybe a few, like a clever bot and Elisa, which is like a psychological chatbot. But um we both, idealistic and philosophers as we were back then, wanted to make it really intelligent like humans. So we just started thinking about what could be the characteristics of a chatbot that is truly intelligent. And so we kept on discussing, and it was like maybe 1 or 2 afternoons. We just spent discussions, walking and talking about all of this. Uh, and that just got me set on this path to build something that is truly intelligent like humans. And also, I am a very forgetful person. So I wanted an assistant that I could just blabber to and remember all of the stuff that I needed to remember for me. So it was also partly laziness that got me motivated into this field. But yeah, we did not make anything during that summer. We did not write a single line of code, but that got me started on this beautiful journey to build human-like intelligence machines. Yep.
Right? Yeah. So how exciting, from 2010 till right now, 2025, it's like 15 years and the world has completely changed. AI has gone through its various winter cycles, up and down. And I think the transformer architecture was the game changer with ChatGPT launching in November 2022. And who would have thought, from November 2022 till now, just maybe like around 3 years, the world has completely changed or upended. And there are so many cool things which has happened. At one point in time, I think technology or things like AI and everything, it was only a domain where only those ones who are vested in the space could kind of tinker around with or understand. Today I think these LLMs have kind of democratized or the accessibility of this AI. Today anybody and everybody can kind of tinker around with AI. Whether you don't know code, no problem. You put in your prompts and it gives you all of these codes. You have like a bug, no problem, and you put in a prompt and it kind of fixes it. It does text to images, 3D world building, and we've got these world models where you kind of put in a prompt and voila, it kind of creates these entire 3D worlds which are interactive. I think these LLMs are completely kind of transformed the world, and I think from here onwards, I mean, the journey from here is just going to be super exciting. Now this term, this artificial general intelligence, obviously, I mean, at one point in time it was like a fancy term and people were throwing it a lot, artificial general intelligence. But now I think there's a pullback of sorts. And they don't want to use that term. And the second thing is also that there's no consensus of how do you define what artificial general intelligence, because I think everybody's got their own definition. Do you have a definition of artificial general intelligence, and do you have a definition of intelligence itself? And will be great if you could also maybe you know share your views on what makes artificial general intelligence maybe different from today's narrow AI system, because even these narrow AI systems is pretty much very, very loaded.
In my mind, artificial general intelligence was, or I still think I stand by that definition as something that can apply knowledge from one domain to another domain. And I think in that sense, AGI has been solved. But that does not mean that we have really solved the intention behind AGI. So, as a term, I define it as knowledge that can be translated from one domain to the other. And I think in that sense, these large language models have achieved AGI. They have these general, to a large degree. I mean, I wouldn't say that completely, but to a large degree, they can take a problem from one domain and or knowledge from one domain and solve another problem in another domain, at least textually, right? So they have that level of understanding that can translate from one domain to the other. So that's why I say AGI as a term, I think, has been achieved. But there's something missing. We all know there's something missing in these large language models. It's still not able to do everything for us. And even a lot of people who are in the frontier labs, they are still working on making these true assistants to humans that could just do anything for us just by talking to it, right? It hasn't bridged the gap between human intelligence, right? Um, so I think a lot of pieces are missing. Um, these systems, they are trained on large data sets and they try to distill out, just the most frequent ideas, concepts that exist. And it is not able to be creative or diverse enough in its responses. There's a problem that is called mode collapse in large language models, meaning that if you ask it to tell a joke, it basically has the set of 3 or 4 jokes that it'll always tell you in the same sense. It's the same joke, they'll just change the names or something like that. So it still is missing this true generality to entropy that humans have. If you ask us to tell a joke, maybe we'll draw on our recent experiences and tell you something that you have not heard before, right?
Yes, I think these large language models are restricted to their data. Anything which is beyond the training data, it becomes a problem. Now there seems to be like a two camps of sorts. One that believes that the scaling alone will get us to AGI. You throw in more compute, you throw in more data, GPUs and stuff like that, and eventually you'll kind of maybe achieve artificial general intelligence. And then there's this other camp, which believes that LLMs are the completely wrong approach. And Jan LeCun, I mean, in fact, says that maybe if you want to kind of build general purpose machines, then LLMs are not the right approach. What do you make of that statement, and what do you make of these current language models? Because I think the progress today also, I mean, like you pointed out, it seems to be completely insane. We have these AI coding agents, and then we have this Google's AI scientist, and some say that these models have like PhD level intelligence. And there was a paper, I think, which was launched just maybe on the 22nd of October by David Silver and team, which highlights that AI models have discovered like a state of the art reinforcement learning algorithm that outperforms human created reinforcement learning or algorithms. So what do you make out of this current language models? Which camp do you fall into? Do you think that these are just stochastic parrots, or we need like a completely different architecture to build AGIs?
Uh, that's a very interesting question. Probably the central question that I keep thinking about myself. I think I do follow the camp where I think LLMs is not the approach to go forward, and that doesn't mean that I trust myself with that prediction that it's absolutely not going to do that. I think I stay cautiously pessimistic about LLMs, and I still try to see if there is enough juice in the actual mechanism to squeeze out and make it really intelligent. So the other day I was watching this podcast between Dwarkesh Patel and
Andre,
Andre.
Andre
Exactly.
Kapare.
Yeah, exactly. And they were talking about how we need to separate out the knowledge from the large language models. So, large language models, if we can remove the knowledge portion, so what it has learned in its training data, if you can remove that and just keep the core principles of how it's able to relate different things together, I think that can take us a long way through. That still doesn't mean that it may be able to take us all the way through, but I think that is a very nice, clean idea if we can achieve that. Now, I still think that there are these fundamental problems um, with backpropagation algorithm itself. So large language models are trained on these uh, algorithms that train it to on large data sets, and these data sets get fed into these models again and again and again and again over multiple epochs, so that learns the it distills that information in the parameters of the model, right? So the problem with that kind of an approach is that there is the separate training phase that happens with all of that knowledge, and then there is this inference phase, or the time when it actually is being used to deliver or serve knowledge to the people. Now the problem there is what is called continual learning or lifelong learning. So these models don't update their weights, they don't update the fundamental knowledge that they have just by interacting with uh, in the real world. And that problem is cannot be solved if we keep using the backpropagation algorithm and stochastic gradient descent. The online learning capability is not being solved for so many years. Like now, backpropagation is so old, and still, and online learning has always been this bottleneck, and people know it from decades now and still not able to solve it. So I think there is that fundamental change that we need to make so that it can learn throughout its lifetime from the data that it's seeing in the real world. So yeah, I am split in the two camps.
Right. Yeah. But because I remember, back in, I think, 2022 November, when ChatGPT was launched. I think the first couple of months, there was these, massive online posts from these researchers, AI researchers, saying that these are just stochastic parrots, and they won't get us anything. But it's surprising what even these statistical data models, what they've managed to do so far. It is so insane. Uh, you are unable to kind of wrap your head around it. So, and yes, I mean, I think these AI today, I mean, they're completely a black box. I mean, though there are these approaches for interpretability, but we still don't really completely understand what's going on under the hood. I mean, so yes, like you mentioned, there are still possibly maybe these bottlenecks, and eventually, I mean, yeah, I think the world is kind of trying to kind of figure out what could be that, maybe like a completely different architecture to kind of build these general purpose machines. Now you've been invested in Lida, the learning intelligent distribution agent. Can you explain that cognitive architecture?
Yeah, so the Lida cognitive architecture, the acronym has been updated since it was originally created. So now it's called Learning Intelligent Decision Agent. It came out of actually that is the history of Lida. Is that so? Dr. Stan Franklin had this grant from Navy, and the sailors who would go out. For many months, when they come back they want to be employed, they want some jobs. So they had this research grant that would allow a system to talk to these sailors and give them jobs in and around where they live. So That is why it was called distribution agent, because it was trying to allocate these jobs through email conversations with them. So the idea is to have them be intelligent enough that they can communicate with these sailors and give them jobs. Um, so the Lida cognitive architecture is fundamentally based around the global workspace theory of consciousness. So the global workspace theory of consciousness says that the uh, the pre-conscious workspace is the stage where there are different actors, meaning different concepts or different cognitive content that we are looking at. So if I'm looking at the screen right now, my laptop, my phone, this plant right here, all of these things are in that pre-conscious workspace as the context. And consciousness is like a spotlight on one of these actors at any given moment. All right. So these don't have to be physical things. They can be conceptual things that you're looking at, an abstract idea or something like that. So Lida cognitive architecture is fundamentally based on global workspace theory, and this is what I call a top-down um, approach to building intelligence. Top-down meaning that it is looking at different parts of cognition, maybe spatial memory, maybe attention, consciousness, um, actions, and it is then composing these cognitive processes and looking at the literature in psychology about how these processes communicate or talk to each other, and then try to build implementations that would accomplish the job of cognition. Um, so this is what Lida cognitive architecture is. It has another core principle that Lida cognitive architecture uses is of a cognitive cycle. So if you think interacting with the world is sensing something, so looking at something or hearing something through our senses, so taking in information through our senses, attending to a particular information based on what is important, and then um, taking an action in the world, right? And we keep doing this again and again and again and again in a cycle. So Lida cognitive architectures is this fundamental atomic unit is cognitive cycle, and we say that based on some neuroscience research that this cognitive cycle takes about 300 milliseconds to complete. And there can be multiple cycles happening like in a pipeline, sort of. So we can have many cycles happening, but typically 300 milliseconds is considered is backed by biological evidence.
What's your intuit over here? I mean, what's kind of missing over here? What's the missing ingredient? Obviously, I mean, everybody's kind of racking their head to kind of figure that out. What's your intuition over here? What's lacking? I mean, what do you think if we kind of are able to kind of model? Eventually, we might get what we are looking for. That artificial general intelligence is its grounded representation, its embodiment. What do you think is the answer? I mean, do you have like an intuit over there?
Yeah. I think I am a reductionist in how I think. So, meaning that I want to try to reduce intelligence down to that basic principle that will allow us to scale it up to a human like intelligence. And um, I think that is why even though I was part of the Lida cognitive architecture, or I still am, um, I think there is that bottom up approach. So LIDA is a top down approach. And I want to say that I fall into the camp of more like bottom up approach, where I try to understand how the circuits in the brain work and how we can distill that into an algorithm that can be scaled up. So that's the bottom up approach, I say. There is a uniformity in the neocortex, the cortical tissue, that the organization of neurons in that tissue is basically same throughout. It's just that different parts are connected to different inputs which make it do different things. So if the organization of that tissue, the organization of neurons in that tissue is the same, then presumably they are doing the similar it's doing a similar thing all throughout, right? That there seems to be an indication of a fundamental algorithm that's running all across the neocortical tissue. So I think if we can build that, and that is not enough. There are other parts of the brain that are crucially important, like the ventral tegmental pathway for dopamine, and that reinforces basically that's the reinforcement learning center of the brain, where dopamine gets involved, and the prefrontal cortex then gets the signal of reward. So we need to build out this fundamental algorithm. Then we need to build out some other systems like the hippocampus in the brain, the reward system in the brain, um, that will allow us to create some of the the crucial items like reward system, memory, and pattern recognition. I think these are the most important parts of the brain that need to be modeled together in order to be able to build something that's intelligent like us.
Right. Yeah. I think, our brain, it's so interesting and unique, and like AI, even in a brain is like a pretty much like a black box. There is so much studies trying to kind of, map and understand the human brain. There is the Human Connectome project, which is trying to map the human brain. And I think we've just,
It's surprising how if you create something as complex as as complex as a current age AI system and the brain both, that they become complex enough that we don't understand the internals of it. There is just some complexity there that humans are not able to understand.
yeah, but yes, exactly. It's so complex and yet so interesting, and I guess there's so many different approaches. There is the Human Connectome project, which is trying to map the human brain. I think Google with Stanford has mapped out like a cubic millimeter of the human brain. What's been going on with the Connectome project is the C. elegans worm, which has only got 302 odd neurons. That's been mapped. Uh, a fruit fly's brain has been mapped. And there are various people who are kind of trying to maybe possibly reverse engineer the brain. There's Liquid AI, which is the MIT spin out startup, which is kind of trying to uh, reverse engineer C. elegans worm, and they build liquid foundation model. There are others who are working towards like maybe like a hardware approach where it's a neuromorphic chip, which is like a brain inspired chip. There are others who are kind of trying to map animals. Where are we? Because I'm I'm still kind of trying to push this a little bit further. Because you also been invested in neuroscience. What are those fundamental blocks at this point in time, because you mentioned, with these LLMs, they are pretty much so much capable. Can there be like an hybrid approach, because there are so many people doing these interesting things, but they all seem to be like having like a separate approach. The Liquid AI may be doing something else, and then there's Neuro AI doing something else, and so many different approaches. You think that there could be like a hybrid approach, which could possibly maybe, show us the first sparks of maybe, building a machine which shows this general purpose intelligent capabilities?
I think that has been the holy grail over at least my career. Is I Ever since I started in this field, there has been this split that there are some people working on your typical neural network architectures, and they think that that scaling will bring us up to truly intelligent machines, and there's this other camp that's trying to build it out of principles in the brain and trying out different approaches, and they cannot even be categorized as one thing. They're all separate approaches to building intelligence. And One trend that has existed ever since is that neuro-symbolic approach, where they're trying to take some of the uh, neuroscience or sorry, neural network based models, and trying to take the intelligence that they learn into some of these cognitive architectures so that you can have best of both worlds. But I don't think that is the approach ultimately to a true AGI or human-like intelligence. Even though I have done some work in neuro-symbolic AI, but I don't think that is the approach that will get us there. Um, I think, again, going back to understanding the fundamental principle of intelligence, and which I think is recognizing patterns, right? So, recognizing patterns and making predictions. That is sort of, I think, ever since I started in this field, has been one of the things that has resonated with me and has come back again through various other research is brain is trying to make predictions always, and you can see how evolutionarily that is important for us, right? If a deer can predict that the rustle that it heard just now could be a predator, then it can save itself and run, right? So we are trying to make predictions in service of actions constantly, and that is the fundamental that is needed to build intelligence. And large language models, to an extent, do that. They are kind of making predictions of what's going to come next, but they're not in service of actions. I think that is sort of the missing link there. Um, and there are no other systems that I can think of that are able to build a predictive action based model of the world. So that is, I think, the missing link.
Right. Pulin, what are your thoughts on these AI agents? Because it's again, it's in the hype cycle, and there are a lot of people who claim that these AI agents can reason, act, and plan. What's going on? What are the what are your views? I mean, is this the hype cycle going overload, or do these current AI agents can they actually reason, act, and plan?
Uh, that is a very interesting question because as much as I don't like to think that LLMs are able to do this, I think if done well, they will be able to do a lot. So I think that um, you might have to build a very specific application for a very specific task. But if you can break down that task into these small pieces of work that a large language model can generate, maybe a function call to do something, and it can write some text for you, and then uh, use that text to write a test case for a piece of code, then I think these kinds of things are very feasible with the current technology. And that is why sometimes I'm amazed that something like Siri is not is taking so much time to incorporate large language models. I think we have all of these actions available in in the Apple ecosystem, or even with Alexa. We have this rich repertoire of actions that an agent should be able to execute on this operating system. And if we have that LLM layer, it understands language and it just has to map it to the right action. I don't think mapping it to the right action is a complex task. So honestly, I am really confused. I really would like to talk to a Apple intelligence engineer and understand what the problems are in executing it, because to me, I don't think it's that complicated. I mean, in a matter of maybe a day, I was able to create a system that could. That was some personal project that I did. I was able to create a system that would look at my to do list and break it down into manageable tasks of maybe 20 minutes and make calendar events out of it. So, I mean, that's just one use case. And if I can do that in a matter of hour, then these large companies with so many engineers can probably do a lot with these systems, and I'm really amazed that it's not able to do that.
Right, right. Yeah, interesting, because I think these AI agents, I mean, obviously, I mean, there are also like these no-code tools, where, like the HubSpots and the Zapiers and the Replit. I mean, they've got these no-code tools also, and they're making it accessible for anyone and everyone. It's natural language interaction. You don't need to actually understand code. You can actually, I mean, do the prompts, and these they create these interesting kind of agents. Now, you had given a talk at the international conference on artificial general intelligence. The topic was, can generative AI be truly creative? I mean, it will be great if you can elaborate on that, because I mean that there's a pushback that these models, these Gen AI tools, I mean, can create out of their distribution, only from their data. If it's out of their distribution data, it hallucinates. Would be great if you could maybe elaborate on the paper.
Yeah, that was a very interesting idea that I had with talking to one of the researchers here, Dr. Arpan Yagnik. He works in creativity, and I was just talking to him. Um, and after that conversation, I realized there, like, how do humans? How, what is that aha movement? How do we get inspiration to do something truly creative? So sometimes I think if I'm solving a problem, and I'm just like stuck on a problem, and I maybe look out of the window and I see a a pole that connects like a pole that is between two wires. So I'll take that concept and I was like, okay, that I was just thinking about my problem, but my problem seems to map to this particular structure. And I was like, okay, I can solve my problem using a pole that connects these two items together. Um, and so somehow I have mapped the structures of my problem into structures of something that I'm seeing in the real world, right? So the idea there was, if we can have the model relate what it is trying to do to something that is random, that is not in the context of the model, then maybe it can relate the two ideas together. For example, so it's really, LLMs are really good at relating two things together, and that is why I say that AGI has been solved, because um, if I ask it to tell me what are the similarities between a clock and an orange, all right, it's very easily able to map that, okay, both of these have segments, both of them have a circular shape. Um, it can find out many different similarities, more than a human can, between these two things, right? That is because of all of the knowledge it has. But somehow, when it is given a context, it becomes streamlined and is only thinking about those things at that moment. So the idea there was very simple. Whenever it's basically a black box technique of making it more creative. When you ask something from large language models, you can ask it to relate it to something completely random, completely different. So, as an example in the paper was, so if I ask a random large language model to tell me a new way of writing code, it gave me very boring ideas, like, you can use visual programming, you can use a chat or large language model to write code or something like that. This is something that we all know. There is nothing new there. So then I had a paisley shirt in front of me, because Dr. Stan Franklin used to wear a paisley shirt, and I wore it to his funeral. So I had that paisley shirt in front of me, and then I was like, okay, let me ask the large language model to tell me a new way of writing code and relate it to a paisley shirt. And what it spit out was maybe micro interactions. So you can use micro interactions to write code. Now, maybe it was not able to, like, already you can see that this is something different. That's something that you have not thought about, that you have not heard of. And so I think they have the capability to be creative. It needs to be elicited from them using some of these techniques. So this also goes back to that mode collapse that I was talking about. So large language models collapse into these one or two broad ideas or a few broad ideas that it has seen in its training time or most frequent ideas. It's not able to pick out those unique things that have not shown up enough in its training data. And so, based on that, we did a follow-up paper where we were looking at the actual impact in the diversity of responses if we infuse a prompt with randomness. So, yeah, I think we can extract some of this diversity. We can solve the mode collapse problem to some degree using these simple techniques.
Sure, there's still room for even these LLMs to become more juicier. So yeah, so I think we in a very interesting point of time. And I think the people around the world, such as yourself, are kind of like pushing and kind of figuring out what more can be done to get some more juice out of these models. Who are the top AGI thinkers or teams, according to you, who are at the in the right path, in your perspective, when you're thinking about like maybe kind of developing this general purpose machines?
Yeah. So I think some very interesting work is happening um, at this Numenta corporation. So I've followed their work for a long time, and they they are basically trying using the same principles that I've talked about. A lot of us inspired from their work as well. Is that the brain is trying to make predictions, and they are trying to build systems that out of sparse representations can build predictive machines that can take action in the real world. And on that note of taking action in the real world, they have a spin-off called Thousand Brains Project, which builds a cortical inspired mechanism for sensory motor learning. And so they are starting to build these simple systems that can recognize an object in a few iterations. So it takes a traditional computer vision model billions and billions of examples before it can recognize an object, and they have a system that can, you know, it's a 3D a 3D environment that these agents live in, and they can just look around that object and recognize it within a few iterations, like maybe a few tens of iterations, 30 to 40 iterations, something like that. So that's something interesting. That's unique. That shows this capability of continual learning that I think is really important. So I think they're doing some really interesting work. Um, there is there is a research lab in Rochester, NGC lab, and Professor Alex Ororbia is the director of that lab, and they have built a system for predictive coding mechanism. So there is this approach that says that brain is making predictions, and based on the errors, meaning whenever the prediction does not match reality, yeah, it is able to learn from that. And that's the fundamental idea behind what NGC Lab works on. And they have built a system that can train neural network like mechanisms on the predictive coding method of learning instead of the back propagation method of learning. So I think that's again going to solve that fundamental roadblock that we have.
Right, right. Pulin, what's your thought on AI being an existential threat? Because at one point in time, Elon used to, shout that AI is something. I mean, AGI is something which could be an existential threat. There's Stephen Hawking, who Max Tegmark, and there's many others. Who, in fact, there's a book recently. I think it's written by Nate Suarez and Eliza Yudkowsky, titled "If Anyone Builds It, Everyone Dies." So yeah, so, and and there's like another book by Roman Yampolsky, Considerations on the AI Endgame. So how should the global research community approach safety and ethical concerns as we approach, maybe in the next few years, we could possibly have or build these general purpose machines?
Yeah, I think the big companies really need to be careful in what they're putting out. Already, I think we are in a risk of slipping into a AI dystopia with all of these fake videos, or uh, because of Sora, we have now videos and images all over the web that we don't know what reality is, which is, I think, really scary. Even like some other days, somebody was telling me that, okay, AI will kill us all like Terminators. I was like, what do you fear more, a psychological thriller or a horror? So I think the psychological thriller is more dangerous than anything else. Is something that we don't even know what reality is anymore. Is bad, but I'm not that pessimistic. I think humans are resilient, and in either event, I think there is no way to stop technology. If I don't do it, somebody else will do it. Um, and putting guardrails is really important. Having having the uh, having the vi- having the mindset of keeping it safe is important. But at some degree, if we are thinking about a system that is contained within a physical machine, let's say my laptop that does not have Wi-Fi connection or it's not connected to any other external source, how much damage can it do, really? Right. So I think when we put it out into the internet, we put it out to the world, we have to be really cautious. So that is why I say these big companies really need to be thinking about these technologies before they put it out to the whole world. But for smaller research labs that are building systems on, a small computer or something, I think we're still a long way from where we need to fear these machines reaching AGI, or reaching human-like intelligence at that level.
Right, true. But from my perspective, I see that we are in like almost like a arms race of sorts. With this AI race, I think the nations are racing towards building artificial general intelligence. These big tech startups are racing towards building artificial general intelligence. Some of the top startups in the world are racing towards building artificial general intelligence, because I think in the back of the head, I think all these nations, big tech, they do understand that if they are able to build these general purpose machines, and what happens is that you get an undue advantage over the other, because it's very difficult to kind of predict what happens post. We have a machine which is general purpose. What could that lead to? Would that lead to a surveillance state where there's one kind of organization, overlooking, ruling the entire world? So it just becomes very, very hazy very, very quickly. You've also done study in philosophy. What's your worldview? How do you see this world? In fact, I think in the course of the conversation, you also mentioned when the reality is hazy. We don't even know what reality is at this point in time. There's the simulation hypothesis and things like that. So would love to kind of get your thoughts on if and when we have this AGI, how do you see society transitioning from where we are currently with this narrow AI? Even this, like you pointed out, it's already going towards the deep fakes. We are creating so much of synthetic content, and with these world models kind of coming in, with these 3D Gaussian splats and things like that. This virtual reality, I see a convergence of sorts. It's like an overload of sorts. The internet is producing so much of data. It's getting very difficult to kind of narrow it down, funnel it to things which is kind of interesting, because you also kind of thinking like, oh, if I miss out on that kind of information, I might there's FOMO is there.
Yeah,
So yeah, so
I'll be
it's
left
like
behind in society if I don't get that
yeah,
information.
exactly. So we're getting into a world which is kind of becoming so overloaded, and because of which, I was just doing a podcast the other day with somebody who's being invested in neuroscience, and And you were saying, mentioning that, how that there's this, like, growth of, people having these neurological disorders. It's like the numbers are, like, staggering. It's kind of like a 3 billion people at this world, in the world currently, who have some sort of like a neurological disorder, and the numbers are growing because we live in a very stressful world. So, somebody who's like also done study of philosophy, how do you see us transitioning, when, if and when we get artificial general intelligence? Even today's world is very, very complicated. How do you see society being impacted, when we, and how do you see us transitioning from this narrow AI to artificial general intelligence?
Yeah. So the work that I've done in philosophy is about sense of self. How does a system, how does an artificial agent can build a sense of self? But I think that is the important aspect that we have to keep in mind once we are in that post AGI world. Is how we can maintain that sense of self in ourselves as humans. Um, it is scary because already, if these large language models are trained on the internet, and half the content on the internet now is from large language models, then what are we getting anymore? What are these large language models learning, and what do we know? How do we know that what they're producing is anything related to reality? So we need to I I th- I think we need to make sure that human connection remains the important thing. We need to be able to still connect with human, not in the virtual world, but in the real world. Um, as much as I like having a video call, it would have been great if you would have been able to do this in person, right? There is something about two people sitting across from one another and having a conversation. We are biologically wired to uh, learn more, to think more, to think better than we are interacting with a person. That is why um, all of the buzz around universities going away as soon as COVID hit. Be like, okay, now everything is going to be on Zoom and the university system is going to collapse and all of that. That does not happen. At least for me, I think I still go into a class just to learn because I like that feeling of sitting in class and learning from somebody who is talking to me instead of talking or looking at a screen, right? So human connection is what is going to keep us in the realm of reality when we are in that, if we come to a dystopian world, I think.
Right. Yeah,
Yeah.
so true. And I hope that we stay connected, because I think we, because of this convergence of sorts, and I've been invested in virtual reality, we've been building virtual worlds, and I know that technology is getting more and more scarier by the day, because we are able to, simulate, sight and sound very well. The sight we can do very well, sound we can do ambisonic spatial sound, which is almost, like how you hear sound in the real world. And what remains is these other three modality: touch, smell, and taste. And there are these companies who are building these brain computer interfaces, which is being hooked onto these virtual reality headsets, and then they'll have like a closed loop interaction, but two-way communication. So what does the world become? I mean, you could be just sitting, and you would be feeling like as if you're eating something, with the taste and smell. So I think it's that the world is kind of more and more going towards that
The
virtual world.
Matrix.
Yeah, the matrix, and it's getting more and more scary. I mean, I see
Yeah.
my son who's like 10 years old, and that age group, I think today, lives on these virtual worlds, these virtual platforms and Minecrafts and Roblox, and it's very difficult to get them off it, because they are natively brought up over there. That's what they know best. I mean, in fact, it so happened, that his friends, whenever they come over, it's so very funny. I mean, because I live in Goa, there's place outside, and you can cycle and stuff like that. They've got their laptops and they're sitting and playing games. side by
Yeah.
side. And I'm
Not
like,
even looking at each other, looking at the screen in
because
front of
they anyway do that. I mean, through, when they talk and they connect through these Minecrafts and Roblox, and when they meet physically, they're supposed to actually meet physically, chat, play, and things like that. But they still in their virtual world. So it's like, I think we're getting into a very, very funny world, and it's so very important to stay grounded and have these human connections, because I think we get going far away from that. The ad industry, the big tech, they keep on selling you these dreams, and we we
Yeah,
the social medias and all.
you're just saying
Yeah.
like that neuroscientists were saying that 3 billion people are already suffering from some problem. And I think anxiety is growing all across the world so much. And I think one of the main reasons of that is the lack of human connection. Anxiety grows when there is so much change that your brain is not able to have a predictive model of the world because it's changing so much and you're not even interacting with people, which is somehow biologically wired into you. And that is, I think, the cause of the anxiety epidemic.
Right. Completely true. Pulin, my last question to you. I think the world is becoming interesting as well as scary. I mean, just I think recently Meta laid off 600 odd people, and who would have thought? I mean, these AI developers would have, would be laid off. Because I think if the tech bros and everyone thought that uh, the last people that would be laid off would be these technologists, but right now that's happening. I mean,
Yeah.
Salesforce and Accenture laid off so many people, and we're seeing that. I think even coding, like people like Himad Mustaq and Insan Wang saying that maybe in the next 5 to 10 years, possibly maybe like coding itself might get redundant. What's your view on that? Where do you see the world in the next 10 or 20 years? Would be great if you could paint a picture of that, your moonshot, as well as maybe advice for listeners, and how do they kind of navigate this world, where things are going like really, really crazy.
Yeah. This is a very, very important question that any youngster from, or maybe even like like typical people who are going into the workforce or are in the workforce and want to progress themselves need to think about. Um, so yes, there has been layoffs, and something like this always is true when a new technology like this shows up. But I think the what needs to happen is there needs to be a shift in the way that people learn so that they're able to be productive in this new environment. That is exactly the conversation we were having in our in our department yesterday, because we need to think about people who we need to build engineers who are now not just thinking about coding but thinking one level higher than coding, right? That is why these layoffs are happening, because we don't need the low level programmer anymore as much as we used to before. We need we need software engineers, architects that can think about how these softwares can be made. The hands-on part can be done by AI right now. Even the craziest examples of the AI being able to create a new reinforcement learning method that you were just talking about. Think about how much human intervention went into building that system that was able to do or build that new algorithm, right? That level of human intelligence, the inventive mindset, the innovative mindset is still needed. As we know that these large language models, they cannot produce something that has not been that they have not been trained on, right? So whenever I try to write a code using maybe vibe coding using for my research, it completely fails. I've stopped using that because it just doesn't know the things that has not been trained on, at least in this higher level idea space. So that becomes the new currency for advancing your career, is having that idea space. And I think the amount of software is going to blow up. Like, we'll have the things that we only used to dream of can happen in an instant now. So if I need a little piece of thing, like maybe I'm having problem in autocorrect on my keyboard, I can maybe quickly spin up a instant that can fix that problem for me, right? And all of these things will become more normal. Like, everyday people will be able to solve their own software related minor problems and things like that. But that's going to take a long time. uh, so that will be my advice for people, is um, keep using AI to build software if they are in the computer science space specifically. Um, but think about that higher level, at one level higher abstraction, about how to build code. But those skills of writing code are still needed, because if it produces a code that's not working, you still need to fix it. So all of that is still important. The moonshot of what I want my work to produce is, if really I can build a system that, I think I'll be happy if I have an assistant that I can just talk to, and it's able to uh, intelligently store anything that I've said and relay it back to me, and be able to do actions on my computer, and be able to think at an abstract level. I think I'll be happy.
Right. Pulin, thank you so much for taking time and being part of the podcast. I think we're sitting at such a fantastic point of time. I think we are at the cusp of the most important time in human history. Maybe in the next 5 years, maybe in the next 10 years, maybe in the next 15 years or 20 years, I'm sure we'll have a machine which will have general purpose intelligence. And from there, I think it really depends on us humans as a collective. How do we see this future? How do we craft this future? Do we craft this adversarially, or do we craft this collaboratively? And I think that that would be like the main thing. I mean, if we collaborate, I think the world is going to be really, really great. If it's an adversarial future, I think then we are going towards the world which maybe the Eliza Yudkowsky is painted. If anyone builds it, everyone dies. So thank you for taking
I
time
hope
and
that
being part
doesn't
of the
happen, and we
podcast.
can
Yeah.
maintain the human connection.
Thank you for being part of the podcast. And
Thank you.
to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, so bye. Thank you. Really
All right.
appreciate
Thank
this.
you.
Thank you.
Bye.
Thank you.